How many of you know what an episiotomy is? How many of you really have no idea? How many of you know and really would rather not know? Okay. So an episiotomy is an amazing little bit of surgical alteration that happens during a difficult delivery. So the kid's head is coming out and the shoulders are getting to the point. Shoulders are more important to get out than the head. Heads tend to get out, shoulders can get stuck. And historically, the reason most women on the planet have died is because as the kid is coming out, tearing happens. You tear through the back of the vagina, which is separated from the anal canal by about that distance. You tear into the rectum, mother becomes toxic and dies. Kid survives. So what they do now is, as the delivery is proceeding, if it looks like there's going to be tearing, you simply go in with a pair of forceps and snip, snip, snip. You make the cuts, open it up. I watched my daughter coming out, and everything is progressing. And I watched the surgeon take a pair of scissors and go in there. I'm going, okay. Oh my God! Wait a minute! There was no anesthesia involved, and there was no screaming involved. In Keflin, let's somebody take a pair of scissors to your vagina, and you can't feel it. Okay, that's scary. Yes. So this set of pathways is very important for reducing pain. You make these drugs because your body hates pain. It can be good for you, but your body doesn't like it. Does everything it can do to avoid pain. And then we have substance P. Substance P has its actions from locus coeruleus down through the ventral rostral medulla here. And substance P is just the opposite of everything else that we've talked about. Substance P allows you to feel pain. You could think of it as substance pain. That's what the P stood for. And it's critical that you feel pain. But that New York Times article goes into the lives of several young kids, and it's mostly young girls, I seem to remember, who have no pain, they can't feel pain. So you go, whoa, well that's kind of cool. In this day and age, you can't feel pain. What could be bad about it? Imagine if you were playing outside, okay? You fell, you broke something, you got up and started chasing after whatever was going on with a broken arm or a broken leg. You go, well, okay, so you got to get the arm and leg set. The reality is when you break an arm or a leg and you don't tend to it quickly and you let the bones separate, the fats in the marrow can get into your bloodstream. What's going to happen to you? You can end up with a pulmonary embolism. What's going to happen to you? You're probably going to die. Whoops, not good. Little boys, and this is why we tend to see this in little girls, but we don't see it in little boys. Little boys are the ones that jump off the garage roof into the swimming pool. Okay? They break something, they get up, they say, whoa, I didn't do that, right? Let me go back up there and do it again. And then they kill themselves. TV shows, books, they've utilized this lack of pain because, believe it or not, pain, as much psychological as physical, is part of your reward system. Now, some people take that kind of to a really bad place where they start to enjoy the pain. They get kind of positive feedback from having pain. So we have sadomasochism. Those types of things. But for most people, we don't like that pain. In those TV shows and books, we've talked about the main bad guy in Girl with the Dragon Tattoo. Did we talk about that? No? Have you read that book?
I've seen the movie.
You've seen the movie? Okay. The American or the Scandinavian? Both. Yeah. They're rough. The books are rough too, but it gives you a lot more insight in the books. So one of the main bad guy in the movie can't feel pain. Did you see just the first movie or all three? Or I don't know how they deal with it in the movie. Can I take you to the end where she finally kills him? Because it's so cool. It's so applicable to this class. So the main bad guy can't feel pain, which means you go to shoot him, you hit him, he's fine. He just keeps shooting you. You go to hit him, you hurt him, he keeps hitting you. So in the end, she finally has him cornered. Okay, he has her cornered. But there's a huge industrial staple gun, you know, that you work on roofs and everything, or what's that called? Hydraulic nailer. She nails his feet to the floor, and he's just kind of stuck there. And I don't remember if she then sets fire to the building or something. But I don't remember exactly what happened after that point. I was just rooting for her to, staple him to the floor. I thought that was really clever. So pain is really important because, believe it or not, your whole reward system fails without your ability to feel pain. When you're learning right from wrong, okay, your parents told you you were wrong. You felt some psychological pain. You did. You get questions wrong on an exam. You feel psychological pain and distress. And that's all okay. That's part of the learning process. So when we don't have this system working properly, there are all sorts of frontal lobe issues. There's parietal pain sensation, but there's also a lot of behavioral stuff. Now, those are some of your endogenous opiates. There are also the non-endogenous opiates, such as morphine, heroin, and opium. Opium was the original non-endogenous opiate. Opium can be smoked, snorted, injected. You can get it into you however you want. So I am told it is like kissing God. The whole point of opium is that it removes pain. It removes pain before you get high. Heroin, same thing. It removes pain. You talk to people in law enforcement, a heroin addict that's high versus a meth addict who's high, or a crack addict. Okay? They'll take the heroin addict any day. They're mellow. Not so with the crack addict, not so with the meth addict. So. And finally, morphine. The the more legal form of heroin and opium, which is what we use to take away pain in a medical setting. Now the sad thing is, you're all going to deal with people that have pain. Pain management for you is going to be one of the most critical aspects of your professional lives. Because without adequate pain management, are your patients going to listen to what you're telling them? And the answer to that is no. Are they going to do repetitions of what you want them to do? No. So pain management is important. Cancers and pain. Pain becomes an outrageous issue with cancer. Pain and terminal cancer, outrageous. It's unfortunate in this country you can't use the same opiate cocktail that they can in Europe. In Europe, for pain management, you can use the three of these together. Person may be out of it, but they have much less pain. So pain management. Please, there are 3 paragraphs in your textbook on pain. Take the time to look at those, okay? The para-aqueductal gray matter is critical to understand. The rostral ventral medulla is critical to understand. You have these 3 major endogenous opiates for the reduction of pain. Please understand where these cell bodies are and where their targets are. Okay? I don't know what else to say, other than we are going to be transitioning to this. Now you look at this and you go, oh, I can do that. That looks kind of like the, it doesn't look anything like the motor. Wait a minute. Yeah. This now gets crazy, okay? No. Everywhere we would have one thing coming out, we have two going in. So that we're going to be talking about losing parts of somatosensation, losing all of somatosensation. We'll talk about what happens when you combine somatosensory loss and motor loss. So we'll be looking at a lot. Getting ready, reading through the pages associated with this and shortly thereafter are critical just so we can all be up and running at the kind of full speed on Wednesday. Because I think, let's see, we're going to go through this on Wednesday. Next Monday, we have a review day built in. Isn't that nice? Because the following Wednesday, you have an exam. Questions? Yes?
Can you go back to the pain?
Oh, I'd love to go back to pain. Which one? That?
Yeah, the red one is the pain receptor, and then go to the spinal cord, and then go to the cord.
Yeah, it's just going, it's showing you the signal coming in, that's all.
Yeah,
This is what's bringing in some pain signal.
Okay, so that one pick up the dorsolateral pick up, and then go to send signal to medulla. It
It would come in, it would go on up, it would get up to the medulla, yep. But this is a descending signal coming down here, okay? So signals coming in here are going to, remember, they're going to cross. Though this signal coming in is shown up there. They're not showing everything in here because it would start to confuse, it would get confusing.
Yeah, so just have to put the first picture and this picture together to see all the...
That would work, yes. But the bottom line here is that this is showing the response at the para-aqueductal gray matter. Para-aqueductal gray matter is critical to responding to pain. Because the signals from this are going to descend through the cord, and signaling within this area is going to get into your CSF, and you can actually have some adequate pain management. Make sense?
Yeah.
Cool.
So send signal down to medulla, and then pick that up and start it.
Yep.
So what is the agreement?
Coming down from locus ceruleus, so just showing you the signal from locus ceruleus, which is substance P. So let's think about it. We have pain coming in, gets on up here. Your brain knows you have pain. This is going to fire so that the signal comes down and says, oh, I have pain. That's all it's showing you. So it's showing you a lot in here. It's tying a lot of stuff together.
Do over-the-counter pain?
Analgesics and stuff like aspirin and
Yeah, do
Excedrin.
those affect this too, or no?
They do a lot of things. They affect a lot of different chemical pathways. And if you'll send me a reminder, I'll put a slide together to go through that. But they affect prostaglandins. They're really bizarre when you really think about it. When you take aspirin, let's say, and you have a toothache, for example. You take the aspirin, your toothache gets better. It's like, why? Why does this get better and my shoulder still hurts? You know, who knows? Different levels of chemical, different targets, different analgesics. And it's really kind of interesting because the analgesics work very differently from opiates, which is why we should have that discussion separately. So throw me an email, remind me. Throw me an email, remind me. Oh God, please email reminders. I'm done. All right, anything else? We all doing okay? Everything else falling together? You're all hanging tight in there?